Welcome to ID the Future, a podcast about intelligent design and evolution.
Welcome to ID the Future. I'm Sarah Chaffee, and I'm pleased to have back on the show today German paleontologist Günter Bechly for an encore interview. We've been talking about the new anthology from Crossway, Theistic Evolution, a Scientific, Philosophical, and Theological Critique. In a previous conversation, we were discussing the chapter Bechly co-authored on the fossil record and the theory of common descent. But the topic is a rich field, with a lot more to explore. When we left off, Dr. Bechly had noted that there were many instances in the fossil record of a dramatic and abrupt appearance of new animal forms, not at all what one would expect from a gradual evolutionary process of small mutations and slow diversification of life. What I want to ask you next, Dr. Bechly, is this. You mentioned that there are close to 20 big radiations in the fossil record, moments where in a geologically brief window, many new animal forms seem to appear out of nowhere. Is there one particular radiation that stands out to you that you would like to share with our listeners?
There are several ones, so I would drop the Cambrian explosion because that is the most well known, and I think more interesting is to hear about some of the other events. So one event that I briefly mentioned is this great Ordovician biodiversification event, which happened in the geological era of the Ordovician about 470 million years ago. And there you had a explosive radiation origin of all those different families of marine invertebrate organisms. More than 300 families appear suddenly without precursors in the older layers. So that would be similar to the Cambrian explosion, but a totally different event. But it has been called in the popular press life's second Big Bang, even though it is much less well known by the general public. There is a preceding event to the Cambrian explosion, the so-called Avalon explosion, where all those weird kind of Ediacaran organisms appear, where no scientist really knows what they are, if they are animals or fungi or strange giant protists or something totally different. But they appear abruptly before the Cambrian explosion, and they have no relationship whatsoever to the later Cambrian organisms. So there's no continuity between them that you could say the Ediacaran fauna is the ancestor of the Cambrian fauna. You cannot even say Ediacaran fauna, the term is used, but fauna would imply that there are animals, but there's no evidence that there are animals or even remotely related to animals. Another events would be in the Triassic. You have several abrupt appearances, for example, all great major groups of tetrapods, that would be vertebrates living on land, walking on four legs, appear abruptly in a relatively short window of time in the Triassic between 251 and 240 million years ago. That would be the first dinosaurs, the first real mammal-like animals, the first relative to lizards, the first turtles, the first relatives of crocodiles, and so on. They appear suddenly out of thin air. There's even a book, a scientific book, mainstream scientific book, which deals with this Triassic explosion event, which is called Out of Thin Air. It's like the Cambrian explosion, but at a later era in the geologic, you have a sudden appearance of marine reptiles in the early Triassic. And what we mention in the book chapter is a study colleague of mine who has to remain anonymous because otherwise his career might be in risk. But he is a paleontologist interested in ichthyosaurs. And he told me when he first realized that the transition from terrestrial supposed ancestors of ichthyosaurs to these complete fish-like animals which are then already appearing in Chinese layers just 4 million years after this great mass extinction event 251 million years ago at the transition from the Permian to the Triassic. There's only 4 million years to go from, let's say, a kind of lizard to a kind of fish-like viviparous marine organism with a dorsal fin and a tail fin and looking like a dolphin. And 4 million years is usually in textbooks the time span, lifespan of a single species. And there's a lot of reconstruction necessary to transform a terrestrial animal into a marine organism. Similar story as in whales. And this colleague told me, even though he's not a theist at all, he's probably some kind of pantheist, not a Christian, even hostile to Christianity. But he told me that this immediately he realized that this cannot be explained with neo-Darwinian evolution. It's much too fast, and that is also one of the indirect evidences from the fossil record, is that the fossil record gives us very well established windows of time for the appearance of certain groups of organisms, for the origin of certain biological complex structures. And then we can use population genetic formula to calculate, is this window of time that is established by the fossil record sufficient for the necessary waiting times for the mutations to appear in a population of a reasonable size and to spread in this population? And what you find is that these times are orders of magnitudes too short, and not in single cases, but in all cases that are interesting. Time is insufficient for Darwinian evolution to take place in the time that is available in the fossil record. So these explosive events, they are abundant. The origin of flowering plants, of angiosperms, was already known to Darwin as an abominable mystery, and it still is. The more we know, the more acute the problem becomes. The origin of placental mammals, they appear suddenly in the lower Tertiary, what is now called the Paleogene, about 62 to 49 million years ago. Basically, all orders of mammal appear more or less with the set of characters that is defining them now. So you have bats that look like modern bats with completely developed wings. And there is no precursor where you could see, let's say, a kind of tree shrew developing vestigial tiny wings and then growing larger over time. They just again appear out of thin air in the fossil record. The same modern birds, all the group of really modern birds, the so-called neo-aves, appear in the early Tertiary very abruptly, and you have orders like penguins about 61 million years ago. And there's another strange fact which shows that there has to be something wrong with the Darwinian picture. If you look at the estimates that are made with genetic data, so-called molecular clock estimates, there is a large contradiction between those genetic estimates and what we find in the fossil record. And these contradictions are so often found that this is not just occasional mistake. There is something generally wrong with this picture. So it's really interesting to compare the real evidence with the expectations of the theory.
So you mentioned a few minutes ago the polyphyletic view of origins.
Right.
It sounds like you've come to that conclusion through the evidence. Could you summarize for us why you think the case for common ancestry is weak and this alternative is better?
Well, actually, I wouldn't say it is weak. I think the case for common ancestry, if we take all evidence, biogeography and vestigial organs and so on together, it would be not really fair to say it's a weakly supported hypothesis. Actually, it's a quite elegant explanation for a lot of data. The question is it the best explanation if you take into account all the data? And my current view would be that these two alternative explanations would be generally on par in explaining all the evidence, common ancestry, compared to a polyphyletic view of, let's say, progressive creation or something. But there is another killing argument, decisive argument, that is common ancestry only makes sense as an alternative explanation in the search for the best explanation of the data if there is a viable naturalistic transformation process that could explain the transition from ancestral species to descendant species, the origin of new body plans, of new complex phenotypical structures, of new genes, of new protein folds, and so on. And what research more and more shows, and especially research that is done in the intelligent design field, this kind of research where our opponents say it doesn't exist, but the time will come that it can no longer be ignored, is showing that this process, this neo-Darwinian process, is not viable. And even a lot of mainstream theoretic biologists who are working on the field of evolutionary biology, they realize that the neo-Darwinian process cannot explain the origin of phenotypical complexity. I attended this conference of the Royal Society in November 2016 in London, and Gerd Müller, a famous evolutionary biologist from Austria, he made a keynote talk and showed a slide where he showed the explanatory deficits of the modern synthesis, and modern synthesis is just a synonym of neo-Darwinism. And he mentioned all these things that we always told: the origin of phenotypical complexity, the sudden abrupt appearance in the fossil record, and so on. It cannot be explained with neo-Darwinian evolution. And then, of course, those scientists, they don't want to give up naturalism, and they look for alternative theories. And there is this whole new field of the so-called extended synthesis, where they look for new mechanisms like niche construction or phenotypical plasticity and so on. But all these alternative explanations have deficits on their own. They either don't address the crucial problems, or if they address the crucial problems, they fail as miserably as neo-Darwinism, or they are ultimately based on neo-Darwinism, because to have phenotypical plasticity or things like so-called evolvability, they have to originate. These properties have to originate, and the only process that has ever been forged or conceived of how could there be a naturalistic way to create information in an iterative bottom-up process without infusion of information from outside is this idea of random variation combined with a kind of selection process. And if this process is demonstrated to be incapable to produce the effect, then basically game is over for naturalistic evolution and also for common ancestry. The point that we didn't make in the chapter, because I also only recently started to make up my mind, is that there is a certain fuzzy border between common ancestry and the polyphyletic view or special creation, which are often posed as if they are mutually exclusive binary alternatives. And I think it is important to distinguish individual descent in terms of parental relationships. So you have parents, mother and dad, and they had grandparents and grandparents and so on. And the question, are there supra-individual ancestors, ancestral species that gave rise to descendant species? And what is implied in common ancestry is that the genetic makeup and the complete also epigenetic makeup of descendant species is basically inherited and modified from the ancestral species. And that, I think, can be falsified and will be more and more falsified with the research on issues like the waiting time problem, on protein folds, overlapping genes, and so on, orphan genes. And but this doesn't exclude the possibility that you still have this individual common descent. So my current position would be, I would call myself a special creationist or progressive creationist. I don't think that descendant species can descend by a naturalistic process from ancestral species. I think the information, the genetic and epigenetic makeup that distinguishes major new body plans or complex structures has to be infused from outside of the system by an intelligent agent. And let's be blunt and call this agent God. And but I wouldn't exclude or currently still favor that these organisms weren't created ex nihilo. Even the Bible doesn't say that man or animals or plants were created ex nihilo like the universe, but they were created from pre-existing matter. And this pre-existing matter could be either dead matter like dirt on the ground, or it could be living matter. So I wouldn't exclude that all organisms, apart from the first living cell, had biological parents and in this sense had individual common ancestors, but I don't think that there is any reasonable way to get from a bacterium to a mammal by a transition from species giving rise to different species by an evolutionary process.
Interesting. So you mentioned that you think that science will be able to test different elements of, did you call it super ancestry or common ancestry? What sort of experiments are you thinking about, and where do you see research going?
Yeah, maybe the first thing that I would mention is a research project that we started 1 year ago, and that is research on the so-called waiting time problem. So neo-Darwinian evolution is supposed to work by random mutation and natural selection. We know by empirical observation that certain innovation needs so-called coordinated mutations. That means you have two mutations that have to come together to have a selection effect, to have an advantage where selection can operate on. And for example, in malaria, Michael Bechly could show that the resistance against chloroquine needed these kind of combined mutation occurring together, and each mutation for itself has no selection effect. And then you can make calculations that we will test different showcases from the origin of photosynthesis to the origin of bird feathers. That will be actually our first showcase, the origin of feathers, to show that the windows of time in the fossil record are orders of magnitude too short to allow for these genetic changes to occur and spread in the population. It's not just sufficient that a single mutation occurs somewhere in the population. It has to occur several times because you have a phenomenon like genetic drift. It could just disappear because the lucky organism who had the first mutation could be eaten by a tiger the next moment, and then you need the mutation to occur another time because it has to be inherited and spread in the population. And there are formula and models, mathematical models, where you can make the calculation. So that I think is one very important field to test. Is there a viable mechanism? And if there is no viable mechanism, then this whole evolutionary story is dead in the water.
Well, thank you so much for coming on the show today and sharing with us about your chapter on the fossil record and universal common ancestry, Dr. Bechly.
It was a pleasure to me.
We've been talking about a chapter from the big new anthology from Crossway Books called Theistic Evolution, a scientific, philosophical, and theological critique. It's a fantastic resource, and you'll find many familiar names there, including Anne Gager, Stephen Meyer, Jonathan Wells, John West, J.P. Moreland, and the man we've just heard from, Günter Bechly. The book has won some great endorsements. I highly recommend it for personal and university libraries. You can find it at Amazon. Again, that's Theistic Evolution, a scientific, philosophical, and theological critique. For ID the Future, I'm Sarah Chaffee. Thank you for listening.
This program was recorded by Discovery Institute's Center for Science and Culture. ID the Future is copyright Discovery Institute. For more information, visit intelligentdesign.org and idthefuture.com.